Do you want me to turn my...
All right, no, it's fine. So you can ask questions as well. It's fine.
Okay.
So X-ray crystallography is how we model proteins. It's quite a complex technique in theory, quite easy in practice. You put a concentrated solution of your protein of interest into a well, use various chemicals, precipitants, soaps, and basically what you want to happen is the solution to dry out. And because the protein molecules are all the same, they'll arrange themselves into a crystalline structure, meaning they are perfectly arranged. So atoms on the front of the crystal are arranged the same as the back. So if you were to shoot an X-ray beam through it, you will be able to see the structure. So you make the protein, or you produce it, or you extract it, you put it into a well, you create what's called a hanging drop. So you flip it upside down, and eventually, hopefully everything else aside from the protein crystal is then in the solution. And you can actually see them under the microscope. They're quite cool. See if I can. Show you mine for my thesis, but I would get in trouble. So you can actually see, and these are real, all different kinds of shapes. So what you're looking for is this.
Oh, wow.
So these only come about when you get perfect arrangement of the proteins, and they make these crystal shapes. It's exactly the same as why salt makes crystals, why you have little salt crystals and sugar crystals. So they arrange themselves in these, they're really pretty. The ones I made were really nice. And the idea is that if all of the protein molecules in there are perfectly arranged, because they're now almost a macro structure rather than a nano structure of protein, we've effectively just times the size by about 1,000. So the idea is that what we're looking for here is how the hydrogens are arranged. Or what we're talking about, the electron density. So we take this protein, or the crystals, we put them in front of a, what are the things where they test the physics? Oh my gosh. A synchrotron, there we go. So if you're in Australia, you'll send your samples to the Melbourne synchrotron. And what they'll do is they'll shoot X-ray beams through it. Behind the crystal is a plate that basically absorbs the X-rays and prints out a computer image of where the X-rays made it through. But what we're looking for is where did the X-rays hit the electrons and bounce back?
Oh.
So the X-rays will hit the electrons in the electron density cloud, which is what we're looking for, the electron density. The computer gives you an image of the shape of the protein and where all of these electrons are distributed around this protein. It has to be perfect though. It has to be a perfectly arranged crystal. If it's not, you'll get some weird funky shape. The electron density won't work. But once you know this electron density cloud, you can send it off to a supercomputer and it will give you an image of what the protein actually looks like. And that is, if we look. Can you see that on the screen?
Yeah.
So
Oh, wow.
you'll get these, and the computer can analyze what the shape is, the arrangement of the electrons, and give you what amino acids are there. You can also look at the 3D shape as well.
Hmm.
So it's just a way to analyze proteins effectively. So the computer will measure, okay, where did the electrons bounce back, or where did they not pass through the crystal? We know there must be an electron there or a hydrogen atom there. And you can model, you can see the ring shapes. So some of the amino acids have the ring shape. And there's the idea called the angstrom, which is how good the image that you'll get. The lower the angstrom rating, so an angstrom rating of 1 is almost perfect. 3, 4, 5, 6, even better. But that basically gives you a clarity of what you're looking at. So you can see the electron density clouds around all of these parts of the molecule. It's all done by supercomputers now. Yeah, so you can see really, all right, you've got a carbon ring here. So we know that that must be this amino acid.
Wow.
Mm.
That's actually pretty cool.
It's interesting. It's probably the most frustrating thing ever, because we had a robot and we would take our protein samples that we were trying to analyze. The robot would make up like thousands of different plates with all different compounds in them to try and get the protein to crystallize perfectly. And you get nothing for 3 months, and then just randomly the computer would try a certain combination, and then you would get perfect crystals.
Oh, so it's actually hard to make the perfect crystals.
Yeah, it's honestly a lot of the time just rapid fire guessing. Because you have to have, and not all proteins will crystallize as well. Only, and if you've got modifications to proteins, then again, it's really hard to make them crystallize. Yeah, it's a fascinating technique. The Rosalind Franklin came up with this in the 1960s. Then she died from exposing herself to X-rays.
Oh.